Good morning or good afternoon, everyone, and welcome to the Lexington Soft webinar. For those of you who don't know me, my name is Dinesh Dilip Singh, and I'm with Lexington Soft. So thank you all for joining us today. So we have an informative topic for today's webinar session. So it's titled Code Coverage and Tool Qualification for Safety Critical Systems. So I would like to take this opportunity to welcome our guest speaker, Dr. Oscar Slatosh. Oscar is the founder and CEO of Validas AG, and he is regarded as an expert in safety standards and compliance with the same. So Oscar, with his team at Validas, provide tools and tests to qualify tools in standard libraries of C and C++. So welcome, Oscar.
Hello, Dinesh. Nice to be here with you.
Thank you. So let me just move on to the agenda. So this is kind of what we have for an agenda. So we will introduce the different coverage levels and how they actually relate to safety critical standards. And after that, Oscar will then educate us on the tool qualification for compliance with these safety critical standards. So we have kind of a quick demo, and we will reserve time for Q&A towards the end of the session. So, and just starting with introducing code coverage. So what is code coverage? It's a measure used in software testing, and it tells you which portions of your code has been executed. But more importantly, it tells you which portions of your software has not been tested. So code coverage is considered a very good measure of test effectiveness. And why measure code coverage? There's a lot of reasons for measuring code coverage. And one of the primary drivers for measuring code coverage is to really instill confidence in the quality of your software. So if you look at this box on the right there, on one extreme, just running a few tests are not going to be sufficient. And on the other extreme, running an infinite number of tests is not going to be practically possible. So with a good code coverage tool, you can just perform as many tests which are required or necessary, but no more than what is required. Also, with code coverage, you can write adaptive test cases to check the portions of your unexecuted code. The other thing you can also do with code coverage is avoid redundancy in testing. And how do you avoid redundancy in testing? So if you actually have a visual overview of the previously successfully executed portions of your code, then you can write adaptive test cases to actually cover the portions of your code that have not been tested. And this way you can avoid redundancy in testing. One of the other reasons for measuring code coverage is also to make sure you can know when you can stop testing. So with a code coverage tool, you can actually set threshold levels, and once you've reached those threshold levels, you can stop your testing. In some industries, you can also prove to your customers that you have good quality code. And also, if you are outsourcing your development activity, you can mandate the usage of a code coverage tool to ensure that your development partner delivers good quality code. Now, one of the other natural outcomes of code coverage is it helps identify dead code. So what is dead code? So dead code is really code that never gets executed no matter what test cases you might write. Coming to the other important aspects of code coverage is it's required in certain industries to obtain certifications, and it is really mandatory for safety critical development and compliance to safety critical standards that we are going to be talking about. So in order to understand code coverage, we need to really look at the different coverage levels, because coverage levels are extremely critical when we discuss code coverage, and these relate to actually safety critical standards. So if you look at the lowest level, we have function coverage or call coverage. And typically 100% function coverage or call coverage is achieved when 100% of all the different functions that are executed. So this is a weak test coverage measure, but regardless, it gives you a rough estimate of the thoroughness of your testing. One level above is you've got statement coverage. It's also called line coverage. And to achieve 100% statement coverage, all the different statements within the functions need to be executed. And then you've got branch coverage or decision coverage, which tells you which branches within the statements are being executed. So it tells you which decisions in your code have actually evaluated to both true and false. Now, a very important coverage level for safety critical development is MCDC coverage. It stands for modified condition or decision coverage. And basically, it's reasonably complex because it requires the following during testing. So one is you've got to ensure that each entry and exit point is invoked. Also, every decision needs to take every possible outcome. Also, you've got to test each condition in a decision to make sure that it takes every possible outcome. And if you add to the complexity there, it's each condition in a decision is also shown to independently affect the outcome of the decision. So you can see it's fairly complex, and basically, if you look at how all this relates to safety standards, you can see that the highest coverage levels represented in this box require all of the more complex coverage levels, which is MCDC coverage, condition coverage, as well as decision coverage. So moving on to the safety standards, we will talk about some of the safety standards here and how they relate to the different coverage levels. So the first one we'll talk about is the IEC 61508. And essentially, the IEC 61508 is a basic functional safety standard, which is applicable to almost all of the industries. And it's titled Functional Safety of Electrical, Electronic, and Programmable Electronic Safety Related Systems. And the safety standard has different safety integrity levels, levels 1 to level 4. And essentially, as you can see, safety integrity level 1 requires only function coverage, which is pretty much the lowest level. And level 2 requires function coverage and statement coverage. But as you get to the highest integrity levels, it mandates pretty much all of the coverage levels and MCDC included. So please make note here, because the plus plus means highly recommended, and highly recommended means it's really mandatory for these standards. The other standards we can briefly touch upon when we're talking about safety critical systems is the ISO 26262 standard. Most of you must be familiar with the standard. It's the standard of the automotive industry for the functional safety of road vehicles. And again, this is has its own automotive safety integrity levels, and there are 4 levels here, level A being the lowest and level D being the highest. Again, as you can see here, level A requires only the statement coverage, but as you get to the highest levels, it mandates different coverage levels, and MCDC is one of them. The other important standard in a different industry is the DO 178B standard, or the C standard. And this also requires high coverage levels for high safety levels. And this is the functional safety for the aviation industry. And basically, the DO 178C levels are defined according to the possible consequences of a software error. So for example, in level A, a software would have a catastrophic impact if there was an error. And in level B, an error means it's hazardous or a severe impact. Level C is still a major impact, and level D and level E are minor or no effect. Again, here, there is no surprise that level A requires 100% of MCDC coverage. It's mandatory because if you really look at the definition of level A software, it's defined as software which would provide or prevent failure of continued safe flight and landing of an aircraft. The other safety critical standards would be the IEC 62304, which is applicable to the medical device industry. And then lastly, we have the functional safety for railway applications, which is the EN 50128. Again, here you've got different safety integrity levels 0 to level 4. And the level 4, you can see, highly recommends all of the different coverage levels. So that's kind of the different safety standards and how they relate to the coverage levels, because the coverage levels, like I said earlier, are a very, very critical aspect of safety standards as well. So it's important you have the right coverage tool, and the most important thing you've got to look at is, does it support all those coverage levels, especially those complex levels like MCDC coverage. So also you're looking for multiple language support. Now, if you're dealing with a code coverage tool, you're traditionally dealing with instrumentation overhead, and you want to look at a tool which has got low instrumentation overhead. The other aspects, especially in with this audience, most likely if you're developing software for safety applications, you are working with embedded targets. And it's really critical that your code coverage solution can actually provide coverage on embedded targets. And if you have targets which are tightly constrained by memory, you have to be able to have a solution that actually can provide coverage data on memory constrained targets. Other things to look at is the comprehensiveness of the coverage reports. And the most important thing also, especially with safety critical systems, is can the tool be qualified for compliance with safety critical standards? Because that's kind of what we're going to be talking about. So other things is also looking at how easily this integrates into your CI/CD workflows, as well as a product got a well-defined roadmap. So moving on to the safety of systems, and before Oscar gets started here, so we are going to talk about the safety of systems, and typically safety of systems involves hardware safety, it involves software safety, as well as tool safety. And they have all one thing in common here, which is standard compliance and safety integrity. And the analogy that I would like to draw here is when you talk about standard compliance, think about it as a safe driver, right? And when you talk about safety integrity, think about it as a safe driver's license. So basically that safe driver's license is a certification that tells you that the driver is compliant to standards. So that's kind of the analogy that I would draw. And in order to really build a safe product, you need a safety plan, and that involves the hardware safety, the system safety, as well as the software safety. And also, it's the tool safety as well, the tools compliance. And there are many components to that, and that includes the tool classification report, the tool safety manual, the tool qualification plan, as well as the tool qualification report. So, and in order to build a safe product, it requires a safety case. If there are functional safety managers in this audience, you probably are familiar with a safety case and what it entails. And what Oscar is going to be talking about is the tools compliance, because this is all about compliance of the tool in your environment for the software that you develop, and making sure that it ensures that it meets the safety critical standards. And the outcome of this is a safe tool usage report. And essentially, that's the holy grail that Oscar is going to talk to you about, because the tool safety manual contains many mitigations for all potential errors. And Oscar will tell you why in a couple of minutes.